Now we'll take a look at finding function and function inverse values from a graph. Finding function values from a graph is pretty easy and something that we've done before. So here's a graph of a function g of x, and the first question asks us, find g of 3. So if we take a look at the x input of 3, we can see the point 3, 1 is on the graph, and so g of 3 is equal to 1. But now we're asked a different question. Find g inverse of 3. So again, sometimes it's helpful to have pictures so we understand the ideas. And so here we have a function g, and then we have g inverse. And the idea is, using the graph, can we find these function values? So for the first problem we did, we input a 3 into function g, and this question asked find g of 3. The answer to that is 1. Now what would g inverse of 1 be equal to? Well, g inverse of 1, we would want it to take us back to our original number, which is 3, because a function and its inverse leave a value unchanged. And so I can see that g inverse of 1 would be equal to 3. Notice that 3, 1 was on the graph of g, then the point 1, 3 is on the graph of g inverse. So let's take a look at this example. We're asked find g inverse of 3. So that means we want to put 3 into g inverse, and the question is, what would we expect to get out? Well, what we would expect to get out is the same value that we initially would have started to put into g that would have given us an output of 3. So this is like reading the graph backwards. All right, so if I take a look at a function value, a y value of 3, notice that corresponds here with the point 5. In other words, the point 5, 3 is on the graph of g of x. If I put a 5 into g, I get out a 3. So if I put 3 into the inverse, what should I get out? I should get out a 5. And so g inverse of 3 is 5. Notice that if 5, 3 is on the graph of g of x, then 3, 5 is on the graph of its inverse. So basically, when you're graphing an inverse and looking at the inverse's graph, the x and the y coordinates have simply changed places. We'll do one more example. Find g inverse of 1. So what that means is that we have a number 1 that we want to put into g inverse, and the question is, what should it be equal to? Well, it should be equal to whatever we put in originally that would have given us an output of 1. And we can see that we already have that answer here in our first line. We know that 3, 1 is on a graph of, is a line on a point on the graph of g of x. So 1, 3 will be a point on its inverse. So g inverse of 1 would be equal to 3. Now that's going to require a little practice, but before we do some practice problems, one last thing. The relation between the graph of a function and its inverse. So we already talked about this idea that if 1, 4 is on the graph of the function, then 4, 1 will be on the graph of the inverse, that x and y simply reverse places. And what does that do geometrically? How does that affect the shape or the look of the graph? Well, here you can see the graph of a function and the graph of its inverse. And the graph of a function and its inverse will be reflections over the line y equals x. So that's this dotted line you can see here. So for example, here's a point, 4, 2, which is on the graph of the inverse. So 2, 4 we would expect is on the graph of the function, and yes, it is, right there. So the graph of a function and its inverse are simply reflections over the line y equals x. Now that we know that, we can graph the inverse of a function pretty easily. So there's a couple of ways you can do this. You can just think about the line y is equal to x. Sometimes it's helpful to draw it into your graph just to kind of keep it as a reference point. And then what I often do is I often find points that I am sure about, like lattice points, and then I graph them on the inverse. So for example, here's a point. That's the point 1, 0, which is on the graph. So then what do I know about the inverse? I know that the point 0, 1 is going to be on the inverse. So 0, 1. Here we go. That's going to be a point on the inverse. Let's do another one. So on the original graph, let's just say this point. What is that point? That's the point 4, negative 4. If that point is on the original graph, then on the inverse, I'm going to see negative 4, 0. So negative 4, 0 would be right here. Let's see if we can do one more. So I think the graph is going to hit this point here, and that's the point 4, 2. So 4, 2 is on the function, then the point 2, 4 is going to be on its inverse. So 2, 4, this point will be on the inverse. So now I have 3 points that are in the inverse. I know what the shape of the original function is, and so that should help me graph my inverse function. So my inverse function would look something like this. All right, time for you to try some.